So, today we are going to begin a topic on measurement. And here's something we need to understand about measurement measurement is a man made invention. So, measurement is essentially designed for our own purposes, for humanity's purposes, in sort of knowing where we're at, for lack of a better word. So, these ideas of measurement, and we'll move on to perimeters, areas, measuring weight, and things like that. These things were invented. We used numeracy, and humans came up with measurement as a means of knowing where they're at. So this dates back to a long time ago. Whether you think of the ancient Greeks using area to measure land, or a number of different things throughout history. Measurement is essentially, for lack of a better word, humans being able to make sense of the world around them. So things like mass, things like lengths of things. We're essentially looking for the magnitude of these different things. And we have created these different metrics for measuring different things. And we've adapted these to certain needs. Now, an example of this, right? And here, this is really just a light introduction and going through some preliminary measurements and measurement conversions. But I won't go too in depth because a lot of these you can look up. And as long as we understand what we sort of mean when we talk about measurement, and as you progress through this course, you'll see that measurement is actually can be quite philosophical, and we'll see why. I'll leave it at that, just to entice you a little bit. But measurement, all we have to understand is that this comes as a result of a human invention to make sense of the world around us. So, say I was to measure my mass, for example. And I'm going to be using here metric units, not US standard units. I'm from Australia personally, so we use, for weight, we use kilograms, grams, milligrams. We, to measure things, we have meters, measuring lengths, I should say, meters, centimeters, millimeters, etc. And I'm going to be dealing with those. So sorry to any viewers from the US, but say I step on a scale. This is my, oh, it's really badly drawn, but I have my scale here. I want to measure my weight, I should say, my mass. So this is me standing here. And I measure my weight to be 85 kgs. Sorry, I keep saying weight. What I mean is mass. There's a distinction between these two. A lot of the time we know we learn things as weight, but there's an important distinction. So I will just say my mass is 85 kilograms. Now, I could also write my mass of 85 kilos using smaller units. And based on some small unit conversions I'll show you, we have that, for example, I have this currently in kilograms. But we as humans have developed an even smaller mass, a smaller unit that is grams. So we know that, well, I'm telling you obviously, that there are 100 grams in 1 kilogram. So, sorry, 1,000, my bad, 1,000 grams in 1 kilogram. And therefore, our mass here, we can rewrite as, if we know there's 1,000 grams in 1 kilogram, in 85 kilograms, there will be 85,000 grams. We can go even further. We've developed smaller units. So one of these is milligrams. There's 1,000 milligrams in 1 gram. So I have an even smaller number. I have 85 million milligrams. So why is this important? We have devised these small, or very large units of measurement based on our needs. Now, something like the mass of a human, it's just not feasible to express this in milligrams, for example. Milligrams would be more suited to something like medicines, which come in very lighter masses. Or if you're a scientist, you may be wanting to measure atoms, which are kind of, in layman's terms, very small, these are very small building blocks of matter. Now, these get even smaller than milligrams. These go tiny. If I was to express these in kilograms, I'd be writing, well, 0.0000. I'd have just way too many zeros to write before I get to my actual mass. So we've adapted these units of measurement and measurement as a whole to tackle real world things, to use essentially as we need them to make sense of the world. I can also go the other way. If I wanted to measure the mass of my car, maybe kilograms aren't enough. I want to go even higher. Now, we won't go too heavily into detail with all of the, big or small. I'm not going to write out all of the different unit conversions for you because you can just look them up online. Really here, I'm just trying to show you the significance of measurement, why we care about measurement. Now, mass is one form of measurement. Another common one we use is length. So you have a ruler, for example, and you want to measure some small distance. Say that we all have, the most common ruler is a 30 centimeter ruler. We have all these little notches and they allow us to measure things. Now, what unit we use, what type of measurements we make, all depend on the purpose we need them for. So if I were to measure the length of a football field, for example, well, I'm hardly going to use 30 centimeter rulers, am I? I'm going to be using some kind of other instrument because we've got a lot of meters to deal with, right? I think a football field would be, I think, roughly about 100 meters. This is just an estimate, but for essentially our purpose that we need, we use different measurement instruments. We use different units of measurements. So the sort of most common to us, at least the one we interact with, is the meter. So we have our 1 meter, and we walk a number of meters around. If we're going for a walk around the block or going for a run, we may use meters or even kilometers. For example, I recently drove to another state in Australia where I'm from. So I drove from Sydney to Melbourne. Now, I'm not going to give you that in meters because I'm just going to be saying too many numbers, right? So too many digits in my number. It's going to be a much bigger number. So I'm going to say, well, that was about 800 kilometers because, well, we know that in 1 kilometer, we have 1,000 meters. We could even go the other way. We could say, well, I'm measuring something small and I want to do that in centimeters. Well, lo and behold, we know that there are, in the units that we have created, there are 100 centimeters in 1 meter. These are all equivalent statements that we've made. So hence this equal sign. They're just different ways of expressing the same thing, but we alter it based on what we're measuring. So another common one, for example, we have 10 millimeters in 1 centimeter, which would mean there are 1,000 millimeters in 1 meter. We could make our measurements even smaller or a lot larger if we're looking at distances between planets and all these large scale things. So the final takeaway here from this little introduction into measurement is that this is this thing of measurement has been created to make sense of the world, for us to understand our surroundings, to analyze the things around us. And we put this in nice little bite-sized terms using units that we can work with in a variety of different contexts, whether we're measuring atoms or the size of planets. There is a huge scale that we cycle through when we're looking at measuring. And measurement, you'll see, has a lot of different applications. Whether you were the ancient Greeks measuring land and looking at perimeters and areas, which we'll go into soon, or whether you're a scientist now and you're an astrophysicist, you're making measurements through space, or you're looking at quantum mechanics, which is, and I know these are very advanced terms for a year 7 measurement course, but I'm just trying to show the significance of how big, how small measurements can get, how we can manipulate these, why measurement is important. And it's very significant because it's been responsible for a lot of our society's development. This has all come through engineers making different measurements and the machinery we use to build buildings, to measure our land, etc. So measurement is a very significant thing, hence why we'll be doing this whole course on it. Now, as I said before, we're going to I'll probably end it here because we'll keep all of these unit conversions that we've laid out a lot more brief for now, because like I said, you can look these up. And we have mass, we have length. So, we make measurements for length along a straight line. So from here to here, we can measure this, and it extends far beyond that. We have time as a measurement, which we're all quite aware of. We have 60 seconds in a minute, 60 minutes in an hour, so on and so forth. We don't need to get through all of them now, but this is just a gentle introduction into measurement and some of the things we're going to be working through and why this is so significant. So I'll see you in the next video.